Hello YouTube. Today we're going to be doing something a little different from our normal math. Normally we would be doing stuff from the college undergrad curriculum, but today we're going to be doing competitive math. More specifically, we're going to be covering problem 2A on the Putnam's 2021 exam. So let's just get started. For every positive real number x, let g of x equals the limit as r approaches 0 of this blob. Find limit of x as x approaches infinity of g of x over x. So right off the bat, this kind of looks like a L'Hopital's problem, just judging from what this looks like, but let's be sure. So first of all, we kind of want to evaluate this limit over here. We'll probably get an answer in terms of x because of the fact that r, we're just plugging things in for r. So if you try to find limit by substitution, you will not be able to get an answer because plugging everything directly in will lead to something that is indeterminate. So we get something that looks like this, 1 to the infinity power, which does not lead to anything. So that does not work. So what we will start off with is taking the natural logarithm of both sides. So let's just say we have the ln of g of x. That is equal to the ln of the limit of all of this stuff. So that would mean that using our properties of limits, we would get 1 over r times ln of x plus 1 to the r plus 1 power minus x to the r plus 1 power, limit as r approaches 0. So where do we go from here? From here, it might seem a bit confusing, like what the heck do you do with this limit? Well, the only way to progress from here is to use the L'Hopital's rule, because if you use substitution, we'll get ln of x plus 1 to the r plus 1 minus x r plus 1 over r, and then if you plug everything in, you get ln of x plus 1 minus x over 0, but then that would just be ln of 1 over 0, or 0 over 0, which is an indeterminate form that is valid for L'Hopital's rule. So now we must differentiate, but we don't differentiate with respect to x, but we differentiate with respect to r. So if you do that, you'll get the limit as r approaches 0 of ln of, not ln. You'll get 1 on the denominator, that's the easy part, and now you'll have to get x plus 1 to the r plus 1 power minus x to the r plus 1 power in the denominator. Get rid of the 1. So actually, we could just put x plus 1 to the r plus 1 power minus x r plus 1 power, and then now you take the natural logarithms. So we can just say x plus 1 to the r plus 1 here multiplied by the natural logarithm minus x to the r plus 1 times the natural logarithm of x. So now we have something that looks kind of messy, I have to say so myself, but now if you try to plug things in, you get something that's a little more friendly to deal with. So you plug 0 in, you'll get x plus 1 ln of x plus 1 minus x ln x over, plug in 0 again, so we get x plus 1 minus x. So we're just left with x plus 1 times ln of x plus 1 minus x ln x. And then you can raise e to this power, because remember, we took the ln, but we never put any e back. Because remember, this is the ln of g of x. So we raise this to the e power, so we get e to the x plus 1 power, multiply everything else. So in other words, we get e to the x plus 1 ln x plus 1 over e to the x ln x. So just erase this here. So this is also equal to e to the ln x plus 1 to the x plus 1 power, or just, well, this is just x plus 1 since the e's cancel out, so this is x plus 1 to the x plus 1 power, and then over e to the ln x to the x power, so e's ln's cancel out, so that's over x to the x power. So now this may look somewhat familiar of a limit. Okay, so we have this as g of x now. So now we're trying to find the limit of g of x over x as x approaches infinity. So limit of x to infinity of this monster we have here. So that's over x to the x times x, or actually that's just x to the x plus 1 power. So that's equal to the limit as x approaches infinity of x plus 1 over x times x plus 1, x plus 1 over x to the x power. And now this may seem very similar to something that we've encountered in the past. So this just goes to 1 because the asymptote approaches 1. So that's 1 times 1 plus 1 over x to the x power, which we already know that's e. So that's 1 times e, or e. That is our final limit, believe it or not.